Welcome. Let's apply trig functions to a navigation problem. First thing that I want to ask you to do is to change this here. In the third line, it says a bearing, well, second and third, north 20 degrees east, and it should be north 20 degrees west. So please cross out that E and change it to a W. Now we can actually do the problem. So first thing I want to go over what this is saying. A boat leaves the harbor and it's at this bearing, south 60 degrees west. Okay. After traveling 55 miles, the boat turns 90 degrees clockwise and travels on this new bearing of north 20 degrees, and that's why I've got it here, north 20 degrees west. And that's going to be for 70 miles. So at the end of that 70 miles, what's the distance and bearing of the boat from the original harbor? So we're looking for the distance and the bearing of the boat from the original place it left at. This is much better started off with a little diagram. One of the techniques of solving word problems can include a diagram. And so I'm going to make one here that looks a little bit like a coordinate plane, but in reality, it's going to be more related to a unit circle. Now, when you're out to sea or basically any kind of navigation, any kind of traveling, you have north and south at top and bottom, usually. You can make an argument that setting up north, south, east, west could be done differently, and you could probably be right. But this is commonly accepted in this order that way, and that's what we're going to do here. So using that, I'm going to do this start with south 60 degrees west. That means going down towards south, but then moving towards the west this 60 degrees. So that means going this way, 60 degrees, because that's towards the west. And that means the boat's going here, 55 miles worth. In fact, I want to put that on the other side so it doesn't interfere with that 60. More towards the end because of what we're going to use later. So 55 miles. Then, according to this, so that takes care of that and this. Now we're going to do a 90-degree clockwise turn. And I'll use a ruler. So I get that to what seems like it is. By hand, it's never going to be perfect. But on the other hand, we can get a reasonable approximation. Now, if that was 55 miles, the next one's 70, I need to make this one a little bit longer. Maybe or maybe not that much longer, but I'll go to about there. And that's 70 miles. And this was a 90-degree turn. And notice that it said that it's north 20 degrees west now. Well, if we were to go straight up north from here, that would make sense because here would be north, and then that would be this amount here isn't very much. So 20 degrees, 20, 25, 30, the way I drew it is probably better if I made a better angle there, and it might look more like 20. But that's about 20 degrees to the west from the north point, or from the north line. So we don't really need to have that on there, and in fact, it's not really necessary, but it is a, well, I guess I'll leave that there anyway. Not really necessary, but then you can see it. I could have actually left this off the problem, just turns 90 degrees clockwise and travels on a bearing of, or travels for 70 miles. But it's interesting to see that that does make sense, then it does work with it. Anyway, back to this. What is the distance and bearing from the original? So let's use that. Back to the original harbor would be here. So what we want is the distance, and we want the bearing. Now, interesting, the bearing is going to be this. All right. So yeah, we need these two. The distance is going to be easier first because we have a nice right triangle. And when you have a right triangle, you can do a squared plus b squared equals c squared, or in this case, one of the distances squared plus the other distance squared is equal to the hypotenuse. So hypotenuse squared, if we want to call it, or radius squared, or whatever. Hypotenuse makes sense here. So let's continue that. We have 55 that'll be squared, plus 70 that'll be squared is equal to the hypotenuse squared, or I even worry about, let's do the square root, because this is a distance formula. This is the same thing as doing the distance formula, and we could have written it up as the distance formula. But still, let's figure it out. 55 squared plus 70 squared, and you take the square root of it. That means that the bearing, you call it the hypotenuse. Oops, it's not the bearing. But the distance now is approximately 89 miles. So we have one answer of 89 miles. Okay, so we've gotten this one. But now we need the bearing. Okay, and the bearing of the boat from the original harbor. And bearings are done from the north or from the south. And so usually we'll use the north one. So that's what we're going to need to figure out here is what is this distance. Now, we want to get what is this amount here. And well, actually, let's go back here. In order to get this one, we're going to need to figure out the angle there, but we don't have much reference with it. What we do have is that this one's 60 here. Okay? So that means this entire amount here would be 120. But what we're going to need to do in order to get this amount, we're going to have to subtract it from the 120. Or we need to know this amount and subtract it from the 120 to get us that one. Yes, that's a better way of saying it. So we need this amount here. And here we'll use a trig function because we have right triangle here, and we call this one our theta. We can now decide to figure out, well, any of these things. We can use tangent, that one over that one. We can use, that's opposite over adjacent. We can use opposite over hypotenuse to do sine. We can use adjacent over hypotenuse to do cosine. Well, I'm going to keep to the original two because I know those are exact numbers. So for the bearing or the angle, I'm going to call it angle theta here. Okay, that one means that the tangent of that angle is equal to 70 over 55. And since I want to know what the angle amount is, I'll do tangent minus 1, tangent to the negative 1, 70 over 55. That will be equal to the angle. Put that into the calculator, and you get that it's approximately 52 degrees. Okay, so if this is 52 degrees here, what we now need to do, we should make that a little bit bigger right here. 52 degrees. There we are. That's that angle. Well, this 120, because that's 60 here. So all of this is 120. I think I'll use the green there. All of that's 120. So now we can do 120 degrees minus 52 degrees, and that gives us 68 degrees. And this is north 68 degrees to the west. So my answer for the bearing, and let's do bearing, is north 68 degrees west, and the distance was 89 miles. Let's review what I did. So first, it was this line, 60 degrees. So that was 1, 2, was drawing that. So I guess 1 and 2 actually were the same thing. 1 and 2 was doing the drawing, setting that up. I'll split them up anyway. The third thing then was to get the distance for part 3 over here to get to 89 miles. The fourth thing was to get 52 degrees by using tangent minus 1, identifying this is what I needed here. And then the fifth thing was sort of easy at that point. Now, in between, it meant recognizing some things. Probably the most complicated of things was recognizing this. I'm going to take a moment and draw that down here. So those who got this easily, great. I'm glad you did, but not everybody does at first. So I want to sort of go over what was happening here. Okay, so I have 55, 70. I now know that's 89. And here are the key things that this is 60 degrees. This is the one I want to know. So what I did is this one is 120 degrees because 120 plus 60 equals, write that as well as I should have, 120 degrees plus 60 degrees is equal to 180 degrees, and that's what this is. The entire thing is 180 degrees. Okay, this 180. That's why I decided that I needed to use 120 here. Get the line back here. This 120, because once I figure out what this amount is, once I figure that angle, then I can do 120, subtract that angle. So this one, actually, I did 120. I wrote that in sort of the wrong place. That whole thing here is 120. This one will be 120 minus theta. And so I needed to find what theta is. And I was able to find theta by doing tangent, 70 over 55. Tangent minus 1 of 70 over 55, and that gave me the angle, which was, what was it, about 52 degrees. Okay, so that's the key thing, figuring out that you needed that angle and then subtracting it from 120. That was the key, sort of the key thinking, or the most difficult, I think, of all this. Some people might have found other parts more difficult, but still. All right, now having done that, this problem here, we figured out that from the original spot where the bearing is 90, that the bearing is north 68 degrees west and 89 miles away. Let's do it again. On this next one, I recommend that you do it yourself. Okay? Pause for a few seconds, work on it, do it, and then come back to either check your answer or to see how to do it if you got stuck. Okay, welcome back to those of you who attempted to do it or not. One way or another, you're hopefully going to understand better with it after seeing this. So we're leaving at a bearing of south 50 degrees east, and it's 10 miles, then turning 90 degrees clockwise and traveling for 30 miles. This time there's no new bearing, just that will be enough here because of the fact that we're going 90 degrees. I'm keeping this kind of problem to 90 degrees because it gives you a nice, easy trig function to work with afterwards. It's still complicated enough, though, to keep you busy, I think. So we're looking for the distance and the bearing. We're going to do the same kind of thing as the last problem. Okay, I'm going to set up essentially unit circle kind of thing. Now, I chose to make it with mostly the third and fourth quadrants because I know what's coming. You wouldn't necessarily know that at first yourself, but I do. Yeah. So we're looking at south 50 degrees east. Here's south, north, east, west. South, and then 50 degrees towards the east, but coming from the south. So that means this 50 degrees, which I would guess would be about here. I could use a protractor to check it for sure, but we don't really need to do that. You can if you want to be really precise, but it doesn't help you for getting the answer if you are reasonable in your guesses for this. Now, I don't want that line quite so long because it's only a 10-mile line. So let's call this one 10 miles. Right? So that's 10 miles here. And then we're turning 90 degrees clockwise, not counterclockwise, but clockwise. So that means if we're facing this way, clockwise would be coming this way. So I'm going to try as best I can. And then this time it's 30 miles it moves, because it's 30 miles, which means about 3 times as long as that 10. So actually I measured this, I did this one as a little more than 2 centimeters on this. 2 and not quite 2.5 centimeters. So 3 times that would be 6 and 7.5 or so centimeters. Okay. So I'm going 90 degrees. This one's going clockwise. And so, whoops, I don't mean for that to come down around there. I need to come here. 2, 3, 4. I don't need to go there. That's good enough. Because what we're looking for here is an approximation of it. Okay, and so this would be, well, that's, if that was 10, this would be about 10, this would be about 20, this would be about 30, maybe about here, more about here, I guess. Okay, so I've gotten to this point, and this is 30 miles. And I know this is a nice right angle. So now what I'm trying to look at is this. Oops. There I am from the center, or from where I started, the harbor where we started. We're now having an emergency, and we have to call back to this harbor and say, we've got a problem and we need help. We need someone to bring us out more gasoline, or to repair the engine, or whatever it might be, or it's a sailboat to help with, rip sails or so on. And those who are sailors know probably they could take care of all this themselves and they know how to do it, but many people would have to call back and ask for help. So let's do it for help here. All right, so we need to know the distance. Well, once again, if I want to know the distance, I can do a squared plus b squared equals c squared, or since all that does is become the distance formula, it's the distance formula of one distance squared plus the other distance squared, and then the square root of those. So it's equal to 10 squared plus 30 squared. Figure that out on the calculator and you get approximately 31.6 miles. Now remember, whenever you take a square root, you get a plus or minus answer, but for a distance, a negative answer is nonsensical. So we just throw it out. So 31.6 miles, then that gives us an approximation there. 31.6. I could have rounded that up to 32, and I would have if it was 31.9 or 8, but 0.6 may be a little too close to just the middle. So I think I'm going to keep it there. But that gives me that distance. So that's one thing, is I've now done the distance. Now the bearing. So for the bearing, what I'm going to need is, compared to the south here, I need this amount here. The problem here is I don't have all that much to go with. Or wait a minute, do I? Well, I do actually. I have this one here. I have this angle. And if I use trigonometry, I can get the full amount of this angle here. I guess I'll do it in the green here. I'll get this full angle so that I can get just this one, because then I can do 50 or whatever it is, take away 50, and that'll give my one there. So I need to figure out for the big angle here, for this one, I have 3 numbers I can work with. I think I want to use the ones that are exact ones, because 31.6 had to be rounded a little. So we'll be more precise if we use 10 and 30. So that means I can use the opposite and I can use the adjacent. And the trig function that goes with that is tangent. So the tangent of the bigger angle that we want, okay, this whole big one here, So I guess I won't put the angle there. The whole thing is the angle right now. The tangent of that big angle is equal to 30 over 10, which is 3 over 1. I'll cancel those out, or 3. The tangent is 3. Well, I want to know what angle goes with that 3, so it's tangent minus 1 of 3 will give me an angle. Okay, and when you put that into the calculator, you get that that angle is approximately 71.5 degrees. Once again, I could round it up to 72, but when it's exactly in the middle there, I want to be a little more precise. So that's the overall angle. And if I subtract the 50 from it here, I'll get what's left. I'll get this one. So subtract 50, and we get 21.5 degrees. And that's coming from the south. That's this angle here. So it's the south going to the west. So it's south 21.5 degrees west. So that's what I want to put for my second answer. South 21 degrees, 21.5 degrees west. In fact, I want to write them both out nice and neatly. Distance, 31.6 miles. And bearing is south 21.5 degrees to the west. Okay. So for my answers, you are required to say, whether it's miles or kilometers or whatever the problem might have, and you must have the south or north and the east or west and the degree sign. Okay. So I will yellow the whole thing in, and then I'll actually use the green one here to emphasize that we need that, we need that, we need this, we need that. And back up on the one above it, notice I put those in there. I had this, I had this, I had this, and I had the miles. Make sure you don't forget those things when doing it. So this was another good example, and hopefully you're able to do it yourself, or if not, now you recognize the parts to it. You know, think of it as, again, part one, part one drawing out that first part two going that way, part three finding the distance using the distance formula. Part 4 was finding the big angle 71.5. Part 5 was then getting the smaller one. And then we're done. We've got our 2 answers. As long as we also recognize that's south and west too. Hopefully this helps. Thank you very much for watching.